Ever wonder if you could jump from one point in the universe to another, bypassing the constraints of space and time? Welcome to an exhilarating journey into the mysterious realms of our universe, where the ordinary laws of physics that we've come to know and understand seem to bend and warp in ways that boggle the mind. Imagine a cosmos not just of stars and galaxies, but of shortcuts. Shortcuts so profound they could potentially let us leapfrog across the vast expanses of space and time. These shortcuts are not your run-of-the-mill detours. No, these are cosmic corridors, bridges between points in the universe that could make interstellar travel as simple as stepping from one room to another. These are wormholes. Wormholes are a mind-blowing concept that originates from the field of theoretical physics, specifically from the realm of general relativity. They're a solution to Einstein's equations that suggest the existence of tunnels through space-time. If you could picture space-time as a two-dimensional sheet, a wormhole would essentially be a tunnel connecting 2 points on that sheet. But, let's be clear, we're not talking about a physical tunnel like the ones we drive through. This is a tunnel in space-time itself. A tunnel that could, in theory, connect not just 2 different locations in space, but potentially 2 different moments in time. It's a concept that's been popularized by science fiction, from Star Trek to Interstellar, but the reality is, wormholes are grounded in real, albeit highly speculative, science. They're a tantalizing possibility that many physicists are actively studying and trying to understand, a possibility that could revolutionize our understanding of the universe and our place in it. But how do these wormholes work? What makes them possible? And could we ever hope to create or find one? These are the questions that we'll be exploring in this journey through the cosmos. So are you ready to explore these cosmic shortcuts known as wormholes? Imagine folding a piece of paper in half and then punching a hole through it. This simple act is a surprisingly fitting way to begin unraveling the concept of wormholes. Picture this. The paper is our universe, and the punch hole, that's our wormhole. So, what exactly is a wormhole? In the realm of theoretical physics, wormholes are considered hypothetical regions of space-time with an extraordinary amount of curvature. Think of them as tunnels with 2 ends, each located in different points in space-time. They could connect vastly distant regions of our universe, different universes altogether, or even different points in time. The idea of a wormhole is a captivating one, largely because it suggests the tantalizing possibility of faster-than-light travel. Remember our folded paper? If it represents the universe, then traveling from one side to the other in a straight line would be a long, slow journey. But if we could create a wormhole, a direct path through the paper, we'd get from one side to the other much more quickly. This is the magic of wormholes. They could potentially allow us to traverse astronomical distances in a fraction of the time. However, it's important to remember that wormholes are purely theoretical at this stage. We've yet to find any concrete evidence that they exist, but their existence is supported by the equations of the theory of general relativity, which describes how matter and energy interact with the fabric of space and time. These equations suggest that space-time can be curved or warped to create wormholes. So, while we may not have found any wormholes yet, the idea that they could exist is not entirely outside the realm of possibility. It's a concept that continues to tantalize and inspire scientists and science enthusiasts alike. In essence, wormholes could be the universe's very own shortcut system. And who knows? Perhaps one day we'll discover that these cosmic shortcuts are more than just a figment of our scientific imagination. Einstein's theory of relativity plays a significant role in our understanding of wormholes. This revolutionary theory, proposed by Albert Einstein in the early 20th century, has shaped our perception of the universe and opened up possibilities that were once considered pure fantasy. At the heart of this theory is the idea that space and time are not separate entities, but are woven together into a 4-dimensional fabric known as space-time. This fabric is not flat, but can be curved and distorted by mass and energy. Imagine a heavy ball placed on a stretched rubber sheet. It would cause the sheet to dip, creating a curve. Similarly, massive objects like stars and planets warp the fabric of space-time around them. But what if this fabric could be distorted so drastically that it folds onto itself, creating a shortcut through space-time? This is where the concept of wormholes comes into play. A wormhole, in theory, is a tunnel-like structure connecting 2 separate points in space-time. It's like folding a piece of paper in half and poking a hole through it. The 2 holes represent different regions of space-time, and the paper's fold is the wormhole. Einstein's equations suggest that such structures could exist. They don't defy the laws of physics. In fact, they are a direct consequence of them. According to the theory, wormholes could form naturally in the fabric of space-time when it is strongly curved by extreme concentrations of mass or energy. However, it's important to note that while the theory of relativity allows for the possibility of wormholes, it doesn't guarantee their existence. We have yet to observe a wormhole directly, but the fact that they could exist according to our current understanding of physics makes them a fascinating subject of study. So, wormholes aren't just a figment of our imagination, they are a possibility grounded in the rules of our universe. But how could we potentially travel through these cosmic shortcuts? That's a question for the next scene. But if wormholes are theoretically possible, why haven't we used them yet? Good question. Let's delve into the challenges of wormhole travel. First off, the most prominent issue we face is the instability of wormholes. Although they are solutions to Einstein's equations, wormholes are incredibly volatile. They collapse almost instantly after their formation, leaving a fleeting window for anything to pass through. Theoretical physicists propose that to keep a wormhole open, we would need something called exotic matter. Exotic matter. Sounds like something out of a science fiction novel, right? Well, it might as well be. Exotic matter is hypothesized to have negative energy density and a large negative pressure. These peculiar properties would counteract the gravitational pull causing a wormhole to collapse, thus stabilizing it. However, the existence of such matter is purely theoretical, and we have yet to find any proof of it in our universe. Further complicating things is the issue of size. The naturally occurring wormholes predicted by the theory of relativity would be minuscule, on the order of 10 circumflex 33 centimeters. That's smaller than an atom. Clearly not something we could send a spaceship through. Even if we could find a way to stabilize a wormhole and somehow enlarge it, we then face the challenge of actually creating one. The energy required to generate a wormhole would be astronomical, far beyond anything we can currently produce. And that's not even considering the technical difficulties of controlling and directing such an energy release. Finally, we must consider the potential dangers. What if a wormhole leads to a region of the universe with extreme conditions, like near a black hole or a neutron star? Or what if the act of traveling through a wormhole is inherently dangerous, causing severe harm or even death to any living organism that attempts it? While the concept seems enticing, wormhole travel is currently beyond our reach. But remember, every great journey starts with a single step. The challenges are daunting, but isn't that true of all great scientific endeavors? Despite the challenges, the exploration of wormholes could revolutionize our understanding of the universe. Just imagine for a moment the possibilities that successful wormhole exploration could bring. It's as if we're on the brink of opening a new chapter in our cosmic story. The potential implications of this exploration are vast and far-reaching. For one, wormholes could become the superhighways of space travel. Imagine being able to traverse astronomical distances in the blink of an eye. Space, as we know it, could shrink dramatically, allowing us to reach the most remote corners of the cosmos. Traveling to galaxies billions of light-years away could become as simple as stepping through a door. Beyond the realm of travel, wormholes could also usher in a new era of discovery. They could provide us with a unique window into the universe, offering glimpses of phenomena that we can't observe from our current vantage point. They might even allow us to peer into other dimensions or universes, if such things exist. Of course, this is all speculative at the moment. There are still many hurdles to overcome. We're dealing with complex physics, immense distances, and technologies that don't yet exist. But that's the beauty of science, isn't it? We're always pushing the boundaries of what's possible. The future of wormhole exploration is certainly exciting. It's a journey into the unknown filled with potential and promise. It's a quest for knowledge, for understanding, and for the sheer thrill of discovery. And who knows what we'll find? Perhaps we'll uncover secrets about the nature of the universe that we can't even begin to fathom right now. Wormholes, while still theoretical, may hold the key to the next frontier in space exploration. They represent a tantalizing possibility, a challenge to our ingenuity, and a testament to our endless curiosity. And as we continue to gaze up at the stars and wonder, we're closer than ever to turning the dream of wormhole exploration into a reality. Please be sure to subscribe to our channel and smash that like button. Until next time.